spacecraft. Taking 10 years and hundreds of scientists and engineers from 5 countries to build, the Juno spacecraft will orbit Jupiter 37 times over the course of 20 months, taking pictures, mapping Jupiter's gravitational and magnetic fields, and measuring the ratio of oxygen to hydrogen to determine the presence of water on the planet. Juno communicates with Earth through a radio wave sent to a radio antenna receiver in Barstow, California, and is managed by the NASA Jet Propulsion Laboratory in Pasadena, California. Juno will be the first mission to explore Jupiter's polar regions, which create ultraviolet auroras hundreds of times more energetic than the Earth's own northern lights. As a gas giant, it is made approximately of 84% hydrogen, 14% helium. These are the lightest and oldest elements in the universe. Jupiter is the largest planet in our solar system with a magnetic field of about 20,000 times more powerful than Earth's, pictured here. It is so large that all of the other planets could fit inside of it with room to spare. The third brightest object in the night sky after the Moon and Venus, Jupiter can be viewed by the naked eye and has long been revered by the ancients. Even though it is the most massive in our solar system, it is also the fastest spinning of all of the planets. The first outer planet outside of the asteroid belt, it acts as a bodyguard for the inner planets, pulling comets and asteroids into its orbit and away from us. It is sometimes called the destroyer of comets for this reason. Jupiter has 64 confirmed moons. The 4 largest moons are Io, Europa, Ganymede, and Callisto. Europa is believed to have liquid water on its surface, below its icy surface, and it is a point of interest for future exploration for NASA JPL. Hailed as the king of the gods in Roman mythology, the spacecraft's name pays homage to history. Juno, wife of Jupiter, was the only one who could see his true nature by peering through his veil of clouds as he attempted to hide his mischief. Similarly, the Juno spacecraft is fitted with powerful instruments that can survive the cold and radiation of space. Will, for the first time, look below Jupiter's colorful clouds and raging storms, using remote sensing from its core to its outer magnetic bubble. Galileo Galilei first recorded the Jupiter system in the year 1610, 18 months after the telescope was invented. Over 400 years later, we can finally help solve the mystery that has captured humanity's imagination at the beginning of civilization. Now on to the Cassini mission to Saturn. The Cassini-Huygens mission to Saturn is pictured here next to Saturn. Christian Huygens was a Dutch scientist who discovered Saturn's rings and in 1655, its largest moon, Titan. Italian Jean-Dominique Cassini discovered the Saturnian satellites, Iapetus, Rhea, Thetis, and Dione. In 1675, he discovered what is known today as the Cassini Division, the narrow gap separating Saturn's rings. Launched in 1997 and landing in 2004 after a 7-year journey from Earth, Cassini is the first man-made object to orbit Saturn. Cassini-Huygens is a joint NASA European Space Agency and Italian Space Agency mission. That is a departure from what NASA usually does, which is independent missions like Voyager and Pioneer. But as we all know, teamwork is best, and we are now joining forces with other space agencies and doing something positive. And it is one of the few positive occasions where humanity gets together. So it's definitely something to be celebrated. So Cassini didn't head straight to Saturn either. The mission involved complicated orbital mechanics. It went past several planets, including Venus twice, Earth, and Jupiter. The nearly 12,000-pound spacecraft was hefted off of Earth in 1997. It went to Venus in April of 1998 and June 1999, Earth in August 1999, and Jupiter in December of 2000. The ESA, this is the trajectory, and it shows all of the flybys that happened to get to Saturn. This is Jupiter as seen from a flyby from Cassini. So the European Space Agency Huygens probe is the first to land on a body outside of the asteroid belt, on the surface of Titan, Saturn's largest moon. The second largest moon in our solar system, and the only one with an atmosphere, Titan is about the size of the planet Mercury. Rich in methane and nitrogen, scientists compare its composition to that of early Earth. This is Titan. During flybys, Cassini took images of cold liquid methane lakes and seas on the surface of Titan, as you can see here. This is definitely somewhere NASA plans on sending missions in the near future. Huygens descended through the mysterious haze surrounding the moon and landed in January of 2005. It beamed back information for nearly 2.5 hours during its descent, and then continued to relay what it was seeing from the surface for about 1 hour and 12 minutes. Here you can see the picture from Titan's surface. It is the first image of a non-Earth planetary surface beyond Mars and Venus. In that brief window of time, researchers saw pictures of a rock field and got information back about the moon's wind and gases as on the atmosphere and on the surface. The mission is known for discoveries such as finding jets, water jets erupting from Enceladus, and tracking down a few new moons of Saturn. Here is Enceladus, and these geysers are believed to power ring E, which is the outermost ring of Saturn. A lot of scientists are wondering what exactly causes the shape of Saturn's rings. It is very thin. It is about 2 stories high, filled with icy rocks. And as they go around each other, they collide and become finer. A lot of scientists are theorizing that it might be some activity in the core that's causing this, and others believe it is actually the moons of Saturn that are pulling and pulling. As we know, the moons of Earth pull on our waves, so we believe that this is a similar mechanism. Now low on fuel, the spacecraft will plunge into the ringed planet in 2017 and capture some data about Saturn's interior on the way. One of the most defining features of Saturn is the number of moons. Excluding the trillions of tons of little rocks that make up the rings, Saturn has about 62 discovered moons as of September 2012. In fact, Cassini discovered 2 new moons almost immediately after arriving, Methone and Pauline. And before 2004 had ended, it had detected Polydeuces. From 2008 to 2010, Cassini flew past Titan 26 times and Euclidus 7 times. It also zipped by Dione, Rhea, and Helene once. Now, the probe is focused on a series of flybys of Saturn's icy moons, particularly Enceladus and Titan. Saturn orbits the Sun every 29 Earth years. By the time Cassini reaches the end of its extended mission, the spacecraft will have been accompanying the planet for about half of this journey. This is a picture of Saturn as taken by Cassini. And that concludes our presentation on the 2 largest planets in our solar system. Thank you very much.
Yeah, the Juno mission, how much time will we be spending taking pictures of the Galilean moons?
I'm not exactly sure how much time it's going to be taking, but I know that it's going to be going around for 20 months. I believe that the main focus is going to be on peering into the clouds. I think there will be some flybys, but I'm not 100% sure on what we're going to be doing with that.
I saw on television this past week a program that spoke of a new satellite that is going to be launched, I think perhaps next year, that is intended to help find answers to the mystery of dark energy. And I was wondering if you could, if you're familiar with that, and whether you could tell us anything about it. I know it's not exactly the focus of this presentation, but so it's fascinating.
No, definitely. It seems as though, as I have not received the teleconference on that, I do not have the information on it. Yeah.
I was wondering about the source of Jupiter's magnetic field. Could it have an iron core like Earth?
That is something we definitely want to track. Whenever we go through, we're going to use the radiometer, and we are going to try to peer into the clouds and see exactly what is going on there, because it is the largest, most massive. It is on the outside of the asteroid belt, but it is the fastest spinning. So that leads us to believe that there is something very powerful going inside, in the core, going on inside of the core. But all we know now is we know nothing.
Aside from satisfying humans' insatiable urge to explore, what do we plan to get in terms of information that will be useful to us in the future in these explorations?
So since it is it's the beginning of the outer planets, so we are venturing out of our house and kind of looking around our neighborhood. Again, we don't know what we're going to find. It's all really a mystery before we find it. Just like before we knew what cell phones were, you know, we couldn't have imagined that the satellites we were sending up there would one day power this information machine in our hands. So we don't know what we're going to find, and we never do. But it's, you know, all mystery, and we're very excited to see what kind of information we get back to the antenna in Barstow. I know that what the main purpose is we want to know how the universe was formed and how Earth was formed, because they are so old and they are so massive, especially the auroras that are so many thousand times more powerful than Earth's. It's like giving a heart surgeon the heart of a whale. Every artery and every vessel is so much larger that it kind of gives us a better understanding and a view on a grander scale of how this operates. And it will give us ideas on how it's powered on our own planet.
It's only been fairly recently that women have been able to be taken seriously in the natural sciences. Could you tell us a little bit about your background, like starting with when you first became interested in science and how you pursued it to get where you are today?
Definitely. So the first time I ever heard about space, I was in 4th grade. And it was very scary, I have to admit. I did not take to it like dip to water. I remember I came back, it was after lunchtime. We sat down and the lights turned off. Presentation like this came on, and my teacher showed all the pictures, especially Saturn. Saturn really scared me. I remember she didn't really explain it. She was just like, this is Mars, this is Jupiter, this is Venus, this is memorize these, the test is on Wednesday. And I remember seeing Saturn and those rings, and I remember thinking to myself, literally, okay, well, that was scary. We're not going to think about that again. So, I didn't think about it until I was about 17 years old, about to graduate from high school. I wasn't exactly sure where I wanted to go, what I wanted to do. I was still questioning the reason for being, and I was on my balcony and I looked up at the sky, which is why I started the presentation as, have you ever looked up at the sky and wondered, where am I? And it's exactly what happened to me. I was just sitting, just a night like any other night, but whenever I looked up, I felt like I was just seeing it for the first time. And I was probably seeing it with newly adult eyes, and I was like, where am I? What is this? And just because it's all I've ever known doesn't make it normal. So I became feverishly curious. What I started doing at that time, I was actually, I graduated high school a little bit early, a year and a half early, and I decided to go to design school, graphic design and all that, and because I've always loved art and I didn't want to commit a lot of money to a university yet and then change my major. So I decided to go to art school for the 2 years that I had left for high school. And whenever I started doing different graphic designs, I started putting together a little children's book about space. So that's what I'm doing right now. I also teach an after-school program for Life Steps USA, which is a nonprofit that contracts with low-income buildings, and we go and we tutor the kids, and I teach them about space and arts and crafts and good design, so all of it kind of goes together. So I started putting together some research, and I came up with a formula that I am planning my PhD around. It's on the theory of everything. I have a basic formula that I think might explain just the basics of what's going on in the universe. So I got in contact with NASA. I told them about my interests, told them a little bit about the research that I've been doing, and they seemed interested. We had an interview, and they said, your solar system is Astro. I was like, of course I will. So now I've done 2 of the things. I remember, as Lindsay said, when I was a little girl, I came from Armenia here, and we were in Princeton, New Jersey, and my mother would take me around to Princeton University, and I would talk to some of the students and teachers there. They would, amuse me as a little girl jumping around. And I remember one of the students, I do not remember his name, but he told me, he said, oh, you're such a smart little girl, you should join NASA and Mensa, and you should go to the Peace Corps, and you should do this. And it really stuck with me. I was like, yeah, that's awesome. And I remember first grade, they said, oh, where would you want to work? And I remember writing NASA, Peace Corps. So I'm 2 out of 3 right now, so thank you so much. This has really been a dream come true. And when I told my mother that, she took it out, and she's like, look, check. So thank you so much for having me today. It has been such an honor and such a pleasure. And I'd love to come back. Any other questions?
How close is NASA to sending a probe to Europa to explore the ocean in Europa?
Very close. Obviously, we are on a tight budget, and we're the first thing to get cut whenever times get hard. But definitely, Europa is on the top of the list, including the lakes of Titan. Moons are on. It's exactly what we're trying to look for, because especially Euclides, now we found the water geysers. So, and then Mars, we've found some water flowing. So we think it's about time to get started on the moons. We've gone to a couple of planets, but the moons are definitely equally interesting.
Are there other solar systems comparable to what we have in the Milky Way? And when we look at the sky, can we see some of these things?
Well, there's all kinds of different systems. There's so many in the galaxy. Comparable in what way? In size and
To know that he exists.
definitely other systems exist. There are 2 star systems where they have 2 suns, and there's just so many different variations of systems. And actually, what's interesting is most stars have companions. So that is also something that we're looking into. All those star systems with I think it's called like the couples systems. So there's a various amount of systems and planets around, yeah.
Are they playing with anything, looking at the fabric of this balloon that we're in, and somehow or other going outside of it? Is there anything, what's the current status of that, if you know it?
That's something that's very interesting because obviously we don't know the shape of the universe because we're inside of it. What I showed you about, the beginning of the Big Bang to now, there is, I should have included it, there is a composite of what the universe looks like. And when you go far, far back enough, it almost looks like the neurons of a human brain, if you go far back enough. So it's very interesting now that we're looking at stars and we're looking at how they're born from nebulas and they have a life cycle and then they die. So all of this is very interesting to us of what we're inside of and if it follows this life cycle of birth, life, and death cycle. So it's all really a mystery. The one thing that I notice about the question and answers is that I have more questions, even talking to the scientists. It's one discovery brings 1,000 branches of new questions. So definitely, we are just barely getting out of the asteroid belt. We are just going almost, we're just discovering down the street, around the block. The whole scope of it, there's still a long time for us to figure out what is the shape of it, and there's also the multiverse theory, the M theory, that they believe that whenever stars explode, 2 things happen. Either they explode and become a nebula, or they become a black hole. And now physicists are theorizing that perhaps in those black holes, new universes are born. So it would be almost like a bubble that branches another one, and it would be a fractal. So that's what they're thinking, perhaps theorizing that is what the outside of the universe might look like.
What is yours and NASA's consensus about life or life forms outside our solar system?
From the scientists that I've spoken to, they think it's highly likely that these elements have come together in the same way somewhere else. Because whenever you look at the elements, it is really, what I call it, it's the alphabet of the universe. Every single one is like a letter, and then when you put them together, you make compounds, molecules, all those things, and they go from words to sentences to novels.